and we can go to the next speaker now. So our next speaker is Victor Lobanov. He's a PhD student at the University of Gothenburg, where he works on nutrient remineralization in aquaponic systems. In specific, he focuses on microbially mediated pathways for waste decomposition and resource recovery as a strategy to promote circularization in controlled environment agriculture and aquaculture systems. So today he's going to present also an AQUAEXCEL project, the outcomes of it. It's called Aqua Waste Improving Plant Health Through Nutrient Remineralization in Aquaponic Systems. So Victor, go ahead, you can share your slides when you're ready.
All right. So I think there's always that button is always kind of hidden.
Not yet presenter mode.
There we go. It's looking good now.
Perfect.
Okay, thank you, Marika, for that introduction. So today we'll be discussing here nutrient remineralization and how we've applied it in the aquaponics context, but it can actually be more generally applied across aquaculture. As we know, aquaculture has a lot of promising growth ahead of it and has already exhibited quite a tremendous amount of growth, especially compared to capture fisheries. However, with that increased growth comes increased waste production. Specifically, aquaculture waste is very rich in a lot of bioavailable carbon and nitrogen, leading to eutrophication. At one point, looked at the amount. If you look at the total amount of aquaculture production in Norway, for example, it's enough energy to power 150,000 homes per year. So we're talking about a very large transfer of energy into our coastal systems. Of course, fish solids are made even more difficult by the fact that they are in that water environment. They're quite dilute, and for that reason, it's not as easy to just put a big net around it and contain it. Probably most significantly, they're not that the incentives are not really there for aquaculture farmers to take the initiative on their own to remove that waste. So as a solution to that, many people have, well, there's a lot of regulation in terms of putting the solids, especially in land-based systems, in some confined area. So largely, generally speaking, that's a settling basin. However, a lot of the infrastructure can get quite expensive. So pumping out those settling basins so that they can be taken to a municipal wastewater treatment system adds a lot of cost. Usually aquaculture facilities, if they're land-based, are in very rural areas, so they're not close to a lot of good infrastructure. So our goal was to take a gander at this and try to focus on an inexpensive but efficient solution. Of course, everybody is always looking for that ideal. So we developed this system where we have a settling basin that can be integrated into any existing facility. And then we have a two-step process, basically first anaerobic digestion, and then we pass it into a sequential batch reactor. So the general idea here is that we create two distinct microbial environments, and they, in the first one, it targets the breaking down that waste, and then the second one, releasing the mineral nutrients. So I won't go too much into detail here, but basically the underlying magic splits these larger fecal particles into, breaks them down into smaller ones, which is entirely done through microbial mechanisms. This releases a lot of methane and carbon dioxide. And so we hope that that can be one example of valorization from the waste. However, for aquaponics, it's quite convenient to use the system because a lot of the mineral nutrients are colloidally bound, so they are only present in the solid waste. And so in this way, we can basically create two outputs, the biogas component and then the mineral nutrient component. Regarding the target market, I am of the opinion that aquaculture in general needs to focus on solid waste capture and treatment, because it's not a sustainable model for us to keep on eutrophying our coastal waterways. But in the short term, we're mainly focusing on recirculating aquaculture systems because they are already concentrating their solid waste. And there are some offshore closed containment aquaculture facilities. Aquaponic facilities, as I pointed out, have a unique way to benefit from the system. However, if we think more long-term, any type of animal husbandry facility could use a similar technology. So in that way, we're trying to focus on what are the inherent mechanisms underway with the solids degradation and conversion to mineral nutrients. And for example, what are specific nutrient requirements that these microbial communities need, so that we can create economically profitable waste revalorization. So there's a lot of unexplored potential there. Currently, we came out with a publication showing that the remineralized nutrients were more bioavailable in a hydroponic system compared to hydroponic nutrient solutions. And this is quite logical, because hydroponic nutrient solutions are salt-derived fertilizers, and it's not usually plants require a lot of microbial infrastructure so that they can integrate those nutrients into their roots. And we've published on that as well, that plants play a very decisive role in choosing their microbial community. And once they've established that, then they can very readily take up nutrients from the water. However, it's best done when those nutrients are delivered already in a microbially mediated way, such as our system provides. We are looking right now we're doing a bunch of experiments to see, to quantify, for example, the biogas output, to determine what is the ideal amount of solids going into the system to maximize efficiency. So as always, there are a lot of research questions left to do. However, we've started the process filing for a patent for the system, because there are several companies that are interested in implementing it in their facilities. So we are at the TRL 4 level. It's been validated in lab in a greenhouse. However, there's a big difference between doing these kind of 1 liter bottle experiments or in a controlled greenhouse environment, and implementing it in a facility that produces 50 to 100,000 tons of trout or salmon per year. So there's the next step basically is to find a more market-ready, implementable product. And yeah, as I'm coming from the research background, this is a new territory for me, so a lot to learn. With that, I think I overcompensated and went a bit too short, but I'd be more than happy to take any of your questions, or you can send me an email. I'm quite excited about the direction that this research is going in, and I want to thank AQUAEXCEL for allowing me the opportunity to do this research and to talk about it right now. And I look forward to future discussions and panels like this.